Hello everyone, welcome back to International Trade. I'm very excited today to continue our analysis of the Heckscher-Ohlin model with the Stolper-Samuelson Theorem, the Rybczkynski Theorem, and the factor price equalization theorem. So let's begin. Recall that we're considering a small open economy with two factors of production, labor and capital. The economy produces two goods, good 1 and good 2, and we have this concave production possibility frontier. We talked last time about the three steps of our analysis. First, we characterize the equilibrium, then we define factor intensity and factor abundance, and then we can study our theorems. Recall that last time we expressed the equilibrium equations in terms of unit costs and unit labor requirements and unit capital requirements. And so we have this unit cost function. We call it the summation of the wage times the unit labor requirement plus the rental on capital times the unit capital requirement. And last time we proved these conditions in red, which would be useful today for the Stolper-Samuelson theorem. Now in equilibrium, we saw it's represented by four equations. There is one system of two equations, which is the full employment condition. And then there is the zero profit condition, so the price being equal to the unit costs. So what we want to do today is take these equilibrium conditions, take some derivatives, and figure out what happens when prices of final goods change, and what happens when the factor endowments change. And recall that we are in a small open economy, so the prices are taken as given. Before we begin, just remind ourselves that good 1 or industry 1 is labor intensive, right? Because they use relatively more workers per machines than industry 2. And then we're also going to think that country 1 is labor abundant, right? But that has to do with factor endowments, and we're actually going to exploit that in the future lecture. Okay, so let's begin with the Stolper-Samuelson theorem. The Stolper-Samuelson theorem. This is taken from two economists, Paul Samuelson and Wolfgang Stolper. Obviously, Paul Samuelson is much more famous. He got the first Nobel Prize in economics in 1970, and he's very famous because he's one of these economists, very rare really, that basically worked in several different fields and left an important mark in each of them. And this is one of the important marks that he left on the field of international trade, this theorem that carries his name. And then was developed at the same time with Stolper, and that's why they both get recognized for this. But so the thought experiment that they propose is to study what happens to factors prices, the wage and the rental on capital, when the price of final goods changes. And so if the price of good 1 becomes more expensive relative to the price of good 2, what happens to wages and rental on capital? To see that, we're going to do some algebra. Right, time to begin our solution of the Stolper-Samuelson theorem. First, recall that our pricing equation equals the PI equals the unit cost CI W and R. And our goal is to show how a change in prices PI is gonna generate a change in the wages and the rental on capital. So what we're gonna do is to take the total derivative of the pricing equation with respect to wages and rental on capital, the total derivative. So total derivative, what we have is dpi equals partial derivative of CI with respect to the wage in the W plus the partial derivative of CI with respect to the rental on capital times the R. Okay. Now, recall that we showed before that the partial derivative of CI with respect to the wage was just equal to the unit labor requirement, and that the partial derivative of CI with respect to the rental on capital was equal to the unit capital requirement. Our total derivative becomes AIL times the, jumping ahead, times the derivative of the wage plus AIK times the derivative of the rental on capital. Okay, so now the trick is going to be to express all of the changes in percentage terms. Okay, so what we're going to do is, first of all, divide both sides of the equation by the price, so that we have dPi over Pi equals to AIL dW divided by Pi plus AIK dr divided by Pi. Excellent. And now what we want to do is to multiply and divide by the wage and to multiply and divide by the rental on capital in the appropriate places. So what we're going to do is dPi over Pi is actually AIL W divided by Pi dW over W, right, plus AIK times R divided by Pi dr over I. Okay, and now notation. We're going to denote with hats percentage changes. So x hat is going to be equal to dx over x. Okay. So what does that mean? Well, that means that our equation becomes Pi hat equals AIL W over Pi W hat plus AIK R over Pi R hat. Okay, so the percentage change in price is Pi hat is a weighted average of the percentage changes in the wage and in the rental on capital, where the weights are these AILW divided by P and AIKR divided by P. Now, we're going to call these weights with the Greek letter theta. So we're going to say that theta IL equals AILW over PI. And theta IK equals AIK R over PI. Okay? And these thetas are the actually cost shares of the two factors of production. So theta IL is the cost share of labor in good I, and theta IK is the cost share of labor in good I. Sorry, is the cost share of capital in good I. Why is that? Well, look at theta IL. So theta IL is given by the ratio between AIL times W. So this is the number of units of labor you need to produce 1 unit of output times the wage. So AIL times W is the number of dollars, the number of kroners that you need to give your workers for each unit of output, divided by the price. Well, that's the share of labor costs over total cost, since the price equals the unit cost. Okay, so similarly, the share of capital cost is the ratio between AIK times R, that is the capital unit requirement, times the rental on capital. So that's the total capital cost associated with producing 1 unit of output, and that is divided by the price, which is also the unit cost. Okay, excellent. So let me rewrite here how our pricing equation look like now. So we have that P I hat is equal to theta IL times W hat plus theta IK R hat. Okay, beautiful. Now our objective is to express W hat and R hat, so the changes in the rental on capital and in the wage, as a function of the change in prices. So what we basically have to do is invert the system. Okay, so let me first write out the two pricing equation for the two goods. Before we begin, let's think a little bit about the labor intensity. Okay. In particular, let us make the assumption that good one is labor intensive. Nice. So good one. So this means that A1L divided by A1K is actually greater than A2L divided by A2K. That is our definition of labor intensity. So relative to the amount of units of capital that good one uses, it uses way more labor relative to good two. Okay. Now, you're going to show in your homework theta 1L is greater than theta 2L. So if good one is labor intensive, it uses a larger share of labor cost relative to good two. Right, so I think this makes a lot of sense. And this also implies that theta 1K is less than theta 2K. Okay, so you show that in the homework is, depending on how good you are in doing mental algebra, it's just a few lines of algebra that comes straight out of the definition of labor intensity. Okay. Okay. So we needed to make this little parenthesis and define the labor intensity in terms of theta, because now what we want to do is write the two pricing equations, P1, P2, in matrix notation. So what are we going to do? Well, we're going to write the P hat 1 P hat 2 vector is actually equal to theta 1L theta 1K over theta 2L theta 2K. And this multiplies W hat R hat. Okay? So now what we want to do is to invert the matrix. We have that W hat R hat is actually equal to 1 over the determinant of that matrix, which we're going to call theta between the two bars. And then we have, well, theta 2K minus theta 1K minus theta 2L theta 1L. And this multiplies the vector P1 hat P2 hat. Okay. Now let's spend a little bit of time on the determinant of the matrix. So theta, that's actually equal to theta 1L theta 2K minus theta 2L theta 1K. Now it is straightforward to show that theta 2K equals 1 minus theta 1K. We know that theta 1L plus theta 1K equals 1. Okay. And also that theta 2L plus theta 2K equals 1. That's because the labor share in good 1 of cost plus the capital cost share in good 1 must be equal to, must sum to 1. All right, so we have is theta 1L, which multiplies 1 minus theta 2L, minus, let's keep the theta 2L, and write it as 1 minus theta 1L. Okay. So what do we obtain here? Well, there's some terms that cancel out, but let's write it out because I'm enjoying this first time on the iPad. Right, so this term cancel with this term. And so what do we get? Well, we get that the determinant is equal to theta 1L minus theta 2L, right? Which is greater than 0, right? Because of what we said ahead about the labor intensity of good 1. Okay, to realize that we can just substitute theta 1L for 1 minus theta 1K, right? Same thing for theta 2L. And so what we get is that theta 2K minus theta 1K, right? So in other words, we can write the determinant both as a function of the labor cost shares or as a function of the capital cost shares. And this will become useful in a second. So having derived the determinant, we can now solve for the wage and the rental as a function of the change in prices. Let's start with the wage. So the change in wage equals, well, theta 2K minus, theta 2K P hat 1 minus theta 1K P hat 2. And none of this is divided by the determinant. Okay. All right, so what can we make of this? Can we say whether it's positive or negative, or whether it's greater than the change in prices? Well, let's see. So here the objective is to somehow isolate one price and then express the remainder of the term as a difference in prices. So here we have at the numerator theta 2k and theta 1k. So it is useful to write the determinant as theta 2k minus theta 1k, as we just showed. In other words, let's write this as 1 over theta 2k minus theta 1k which multiplies theta 2k p hat 1 minus theta 1k p hat 2. Okay, so what can we do now? Well, as I said, this will become clearer in a second, but the objective here is to isolate a price. In this case, we're going to isolate p hat 1. And so what we're going to get is w hat is actually equal to, is what we're going to do, theta 2k p hat 1 minus theta 1k p hat 1 plus theta 1k p hat 1 minus theta 1k p hat 2. And all of this is divided by the determinant. Theta 2k minus theta 1k. And doing this, what we obtain is that w hat equals p hat 1 plus theta 1k over theta 2k minus theta 1k times p hat 1 minus p hat 2. Okay, so now you're saying, okay, Luca, this is all nice. Now we have a nice expression that relates the change in the wage to the change in the prices of the two goods. What can we do with this? Well, suppose that p hat 1 is greater than p hat 2. This means that the relative price of good 1 is increasing. Okay, so this is fairly general because both prices can be increasing or decreasing. All we care here is what happens to the wages and rental on capital if the price of good 1 is higher relative to the price of good 2. Well, it is very quickly to show that if this is the case, well then this term here is greater than 0, and so this means that the wage is greater than p hat 1. All right, so what we obtain is that the wage w hat is greater than p hat 1, which is greater than p hat 2. So the percentage change in the wage is higher than the percentage change in the price of good 1 and the percentage change in the price of good 2. Workers are better off. Let's now move to the rental on capital. Okay. So here we need to look again at the matrix notation that we wrote here, right? And so what we have is that r hat equals minus theta 2l p hat 1 plus theta 1l p hat 2. And all of this, because we don't need to go back, is divided by the determinant. So how can we develop an equation that resembles the one for labor? Well, in this case, we're going to isolate p hat 2 I'm going to write the determinant as a function of at theta 1L and theta 2L. So we have is that our hat equals theta 1L p hat 2 minus theta 2L p hat 2 plus theta 2L p hat 2 minus theta 2L p hat 1. And all of this is divided by the determinant, which again is equal to theta. In this case, we're going to use a theta 1L minus theta 2L. So what we get is that p hat 2 minus theta 2L over the determinant theta 1L minus theta 2L, which is positive, times p hat 1 minus p hat 2, right? Recall that we assume that p hat 1 is larger than p hat 2, so that this term here is positive. And so what we have here is that the rental on capital changes, the percentage change in the rental on capital equals the percentage change in the price of good 2 minus something that's positive. So that means that the rental rate on capital hat is less than P2 hat. And so what we get is that P hat 1 greater than P hat 2 is also greater than the rental on capital. And so this means that the rental on capital increases less or changes by less than the change in the price of good 1 and the price of good 2. So if you're a capital owner, you become poorer in real terms because you can afford fewer units of good 1 and good 2.
And so this is the Stolper-Samuelson theorem. So what we have is W hat is greater than P hat 1, greater than P hat 2, greater than R hat.
All right, so after all that algebra, we can enunciate the Stolper-Samuelson theorem, which says that an increase in the relative price of good will increase the real return to the factor used intensively in that good, beautiful, and reduce the real return to the other factor. So if the price of good 1 increases, and good 1 is labor intensive, the factor used intensively in the production of the good labor will experience an increase in the real wage. Okay, so if you can think that the best friend of labor is the price or is the labor intensive good, so that if the labor intensive good becomes more expensive, workers are better off because they can purchase more of the labor intensive good and on the capital intensive good. However, an increase in the relative price of the good will reduce the real return to the other factor. So if the price of the labor intensive good increases, capital will lose, right? Because the real rental rate on capital will be lower. So capital owners can only buy fewer units of good 1 and of good 2. So this is wonderful. Why is this happening? Let's derive some intuition. The key mechanism here is that the price of a good increases and therefore production will adjust. So if the price of the labor-intensive good increases, production of labor-intensive good also increases. right? I mean, that makes perfect sense. If the price of a good goes up, people would like to produce more of it because they can make more money. Right? That's what was happening in the Ricardian model. We trade, the comparative advantage good becomes more expensive. That's why you specialize in the production of it. Right? So you want to produce more units of the labor-intensive good. What do you need? You need factors of production, labor and capital. Where do you get them? From the other good, from the capital-intensive good. So you want to reduce the production of capital-intensive good to free up some labor and capital that can be used in the production of good one, of the labor-intensive good. Now, the key here is that the two goods differ in their labor intensity. And so I apologize here for being not very precise, right? But it's as if when you reduce production of the capital-intensive good, you're freeing up more capital than you need. Okay? Obviously, saying need, I put it under quotation marks because it's, it's not a terminology that you would hear often in an economics course, right? But I think it conveys the message here. You want to free up labor and capital from the capital-intensive sector and move it to the labor-intensive sector. And so by doing that, you're freeing too few workers relative to what you need and too much machinery relative to what you need, right? Because you go from capital-intensive to labor-intensive. So given that there is this sort of mismatch, what happens? What happens is that there's a lot of capital floating around that you don't really know what to do, but you desperately need workers and there aren't as many of them. And so when you want to produce more of the labor-intensive good, you free up capital and labor, but you free up more capital than what you need. So capital is plentiful, its price will go down. And you also free up less labor than what you need. So labor is very scarce, and so its price will go up. And so this is a way, an intuitive way to think about the intuition or the motivation for why the Stolper-Samuelson theorem works. So another, an alternative way to also think about it is to basically realize that capital intensity increases in both sectors. Okay, so again, you move machines and workers from industry from industry 2 to industry 1, from capital intensive good to labor intensive good. So you're freeing up more capital than you need than workers. And so you're basically moving more capital relative to workers in industry 1, and therefore there's now more machines per workers in industry 1 as well. And then you can also think the same thing for industry 2. In industry 2, both capital and labor leave, but since industry 2 is capital intensive, there will be a larger move away of workers relative to machines. So even in industry 2, capital intensity will increase. Okay? So as you move workers and capital from the capital intensive sector to the labor intensive sector, capital intensity in both sectors increases. And so that means that the marginal product of labor goes up because to each worker, you're giving more machines. And so if the marginal product of labor increases, that means that the wage will increase. Similarly, the marginal product of capital will decline in both sectors, and therefore the rental on capital will also decline in real terms. Excellent. Obviously, if you have any questions, please send me an email or upload the questions with the link that I provided on Blackboard. So this is one of the limitations of this online teaching, that I cannot see in the eyes and see if I'm making any sense. This would have been a much more animated presentation if we were in person. But so aside from that, what really sucks for me is not knowing if you understand what I'm doing. So please give me some feedback on that. Another question by Tadeusz Rybczynski, which don't worry too much about the spelling. If you're in an exam and you don't know how to spell it, that is okay. Here, we're going to study a different question. We're going to study what happens to the quantities produced when the endowments change. So suppose that the number of workers increases. Suppose that the number of units of capital increases. What happens to the output produced by a country, holding constant the international prices of final goods? Okay. Now, to answer to this question, we're also going to do some algebra. You see, it's going to be very similar to the Stolper-Samuelson theorem. But before we do that, let me speak a little bit about this algebra. So the reason why I'm showing you the recording of the algebra is to generate an online lecture which is as similar as possible to the in-presence lecture. Obviously, there'll be something that will not be will ever be matched by that, but at least you can see how fast I derive these things. You can derive these things along, and I really recommend you do that. So now let's go back to the Rybczynski theorem with the derivation. All right, let's start with the Rybczynski theorem, and let's start by writing down the full employment condition for labels. So that y1 a1l plus y2 a2l equals L bar. Okay. The objective of the Rybczynski theorem, as we said, is to study how a change in the total factors of production, in the endowments of the factors of production, L bar or K bar, is going to affect total output, holding constant the prices of final goods. Now, by the Stolper-Samuelson theorem, if the price is P hat 1 equals P hat 2 equals 0, implies that the percentage change in wage also equals the percentage change in the rank done of capital, and they both equal 0. And so if the wages and the rental on capital does not change, well, that means that your unit labor requirement and unit capital requirements, which are a function of the wage and the rental, will also remain constant. So A1L, which is a function of W and R, and A2L Okay, excellent. So now what we want to do is take the total derivative of the full employment condition. So what we have is that d y1 a1l plus dy2 a2l equals the L bar. Okay, so now we're going to do a similar trick to what we did in the Stolper-Samuelson theorem. So what we want to do is express everything in percentage changes. So we start by writing that we have is the dy1 divided by y1 times y1 a1l plus dy2 divided by y2 times y2 a2l is actually equal to d L bar. We want to divide this by the total factor endowment L bar, but that also means that we have to divide it everywhere. So let's do that. And then we can write everything in terms of percentage changes. So y hat 1 times y1 a1l divided by L bar plus
y hat 2 times y2 a2l divided by L bar equals to L bar hat. Okay, so the percentage change in the factor endowment of labor is a weighted sum of the percentage changes in the two outputs, where the weights are these terms y1 times a1l divided by L bar. Now, similarly to the Stolper-Samuelson theorem, we're gonna denote with lambda 1L the ratio y1 a1L divided by L bar. Okay. And lambda 2 L is going to be equal to y2 over a2L divided by L bar. Now, these lambda terms are the share of workers employed in the two industries. So lambda 1L is the ratio between y1 and a1L. So that is the total output in industry 1, y1, times the unit labor requirements, so the number of workers you need to produce 1 unit of output. So y1 times a1L is the total number of workers that are working in industry 1. If you divide that by L bar, what you get is the share of workers that are employed in industry 1. You can do the same thing for industry 2, and you can do the same thing for the capital shares employed in the two industries. Now, it follows that lambda 1L plus lambda 2L is actually equal to 1. Okay. Now, using these equations, using these two definitions of lambda 1L and lambda 2L, we can rewrite the system of equations as lambda 1L y hat 1 plus lambda 2L y hat 2 equals to L bar hat. Now you can do the same thing for capital, and what you're gonna get is that lambda 1k y hat 1 plus lambda 2k y hat 2 is actually equal to k bar hat. Excellent. Now recall that good one is labor intensive. In the homework, you're going to show that this has a straightforward implication for the lambdas. Lambda 1L is greater than lambda 1K. And therefore, that lambda 2K is greater than lambda 2L. I mean, this is sort of intuitive, right? This is saying that the share of workers in industry 1 is larger than the share of capital in industry 1. And I mean, this makes sense, right? So if you had, 60% of your workers in industry 1, you couldn't have 70% of capital also in industry 1 if you want industry 1 to be labor intensive, because that would mean that there is relatively more capital employed in industry 1 than there is labor employed in industry 1. Okay, so now that we make this conclusion regarding the labor intensity and capital intensity of the two sectors, we can proceed with writing the system of equation in matrix form, so that L bar hat K bar hat equals lambda 1L lambda 2L, lambda 1K, lambda 2K, y hat 1, y hat 2. Now we're going to invert this matrix, and so we will obtain the y hat 1 divide y hat 1, y hat 2 equals 1 over the determinant of the matrix, which we're going to denote as lambda between the two bars, as if it was an absolute term, absolute value. What we have is lambda 2k minus lambda 2l minus lambda 1k, lambda 1l. And this multiplies the vector of the endowments changes. Okay, excellent. Now what is the determinant equal to? The determinant is lambda 2k, lambda 1l minus lambda 2l, lambda 1k. Now, using our result that the sum over the goods within a factor of production of the lambdas equals to 1, we obtain that lambda 1k, sorry, let's keep it lambda 2k times 1 minus lambda 2l minus lambda 2l 1 minus lambda 2k. And so this is equal to lambda 2k minus lambda 2k lambda 2l minus lambda 2l plus lambda 2k lambda 1l. So, sorry, lambda 2l. And so this term cancel out with this term, and so what we get is lambda 2k minus lambda 2l, which is greater than 0. Okay? Great. So now let's assume that L bar is positive and that K bar hat is actually equal to 0. Right, so there is an increase in the number of workers, but there's no change in the endowment of capital. What does that generate in terms of changes in output? Well, let's solve our matrix there. So what we have is that y hat 1 is actually equal to lambda 2k over lambda 2k minus lambda 2l times L bar hat, right? And this term is positive. What about y2? Well, y hat 2 equals minus lambda 1k divided by lambda 2k minus lambda 2l times L bar hat. Which is less than 0. So here we have the Rybczynski theorem. So if L bar hat is greater than 0 and K bar hat is equal to 0, the output of good 1 will increase and the output of good 2 will decrease.
All right, so we did it. This time not owl because it was quicker, also because it was much more similar to the Stolper-Samuelson theorem, right? At least in terms of derivation. And what we've established is that if there is an increase in one factor of production, in our example, labor, there's going to be an increase in the output of the industry that uses that factor intensively. There's going to be a decrease in the output of the other industry. So graphically, here we have a production function, production possibility frontier. And we have the capital intensive good on the vertical axis, the labor intensive good on the horizontal axis. And we're going to see what happens with an increase in L bar. Well, what we established is that there's gonna be a shift outward of the production possibility frontier. Notice that both the number of the capital intensive good and labor intensive good that you can produce if everybody's working there both increase, right? Because you can always add more workers everywhere. But the increase is skewed towards the labor intensive good. And if you hold the prices constant, what you see is that basically there's going to be, yes, perhaps it's not that evident, there's going to be an increase in the labor intensive good and a reduction in the capital intensive good production. So what is the intuition for this result? Well, first of all, recall that if the prices of final goods are constant, then wages and rental on capital will be not changing, right? So that's what we showed last time. So a way to think about it is that if the prices of final goods do not change and the wages and rental on capital do not change, that also means that the labor intensity in both sectors have to remain constant, right? Because if you change the labor intensity, if you say increase the number of workers per machines, then that's going to affect the productivity of labor and capital and therefore their wages and rental. But we've established by assumption, right, that the wages and rental are constant. So how can we maintain labor intensity constant across sectors when we increase the total number of units of labor? Well, we have to put all the new labor, right, to the labor intensive sector. And then we also have to move away both capital and labor from the capital intensive sector. Right? Why is that? Well, if we increase workers in industry 1, that means that labor intensity will increase. To keep it constant, we need some capital, which will come from the capital intensive industry. But if in the capital intensive industry we take away capital, that's gonna increase the labor intensity. We don't want that, and so we're also gonna move labor. And this trick works because we're moving capital and labor from a capital intensive sector to a labor intensive sector. Right? So the requirements are different. In the labor intensive, we need fewer machines per worker than in the capital intensive sector. And so that's why this works. An important implication of the Rybczynski theorem is the Dutch disease or resource curse. So the idea that when a country finds some natural resources in its territory, that could be a curse, that could be a disease, that could be problematic. This comes from the fact that when they found natural gas in the Netherlands, there have been a decline in the production of manufacturing sector, and an increase in the production of natural gas. This is due in part by the changes in the exchange rates, but we don't talk about that in this course. But it's fairly straightforward that according to the Rybczynski theorem, if the factor endowment of one factor increases, to say the natural gas or oil or anything of the sort suddenly increases because there's a new discovery, then holding constant the prices of final goods, there's going to be a shift in the factors of production towards the sector whose intensive factors endowment increased. So if a country discovers natural gas, it means that the capital in the natural gas industry has increased. Right? And so workers and capital from the other sector will move to that sector. Okay? Now this is particularly problematic, right? Because of several reasons, but this is particularly important in African countries. Here I'm reporting just a few lines from an article of the Financial Times of last October, where basically is talking about Nigeria, one of the biggest countries, if not the biggest country in Africa in terms of population. And you see that its economic growth is being plagued by the fact that they had oil. You can see here environmental activists complaining about this, not because of the environment necessarily, but because the country has been primarily focused on oil extraction. As a result, does not have a thriving manufacturing sector, and as a result, there's not the productivity growth that typically comes from the manufacturing sector. And on top of that, you can see that these extractive sectors are often very easily becoming corrupted. Last theorem is the factor price equalization. We're not going to have any analytical derivation for this. Not even Finstra, when I took his course, did that. So I'm confident this is the way to go for this theorem. But what this theorem is saying is that when two countries trade, if they have the same technology, but they have different factor endowments, of course, both goods are produced and there's no factor intensity reversal, meaning if a good is labor intensive at any level of the wage and the rental on capital. Okay, there's no combinations in which the labor intensity reverses between the two sectors. Then factor prices are equalized across countries. So this is perhaps a bit surprising, but if we go back to the equilibrium conditions, when two countries trade, they're basically sharing the prices of the final goods, right? Because the prices of the final goods are the prices determined by trade. And what happens is that if there's no factor intensity reversal, right? If AIL over AIK is always larger than A2L over A2K, there are not any changes, you can think that there is a one-to-one mapping between the prices and the relative wage and rental on capital. Okay, and so if the prices are the same between two countries, also will be the wages and rental on capital. You may think, wait a second, but that doesn't hold in the data. That's not true. We saw it last time that wages are different across countries. And of course it's true, wages are different across countries. And we saw it last time because it's because of the technological differences. Right? Some countries have better technology and absolute advantage than other countries. But that is outside of this model. And what this factor price equalization is telling us is that when technology is the same across countries, the two countries do not need to open their borders to the movement of capital and workers, because what's going to happen is that trade is going to equalize wages and rental on capital. Okay? And so this is very important, right? Because this is putting an equivalence between movement of goods and movement of factors of production when it comes to wages and rental on capital. Okay, that's it for today. Thank you for watching. See you next time. Ciao.